What if the search for alien life isn't happening on Mars or a distant planet, but at the bottom of Earth's own ocean? Deep inside the Mariana Trench, a place so hostile that even advanced technology struggles to survive, NASA is studying conditions that may hold the key to one of humanity's biggest questions. Are we alone in the universe? For decades, NASA has looked toward the stars in search of life beyond Earth. Massive telescopes scan distant worlds. Spacecraft travel billions of kilometers through the solar system. Robotic explorers search barren landscapes for signs of ancient water. But while the public watches the skies, another mission has been unfolding much closer to home. A mission that leads not upward into space, but downward into darkness, to a place where sunlight has never existed, a place where the pressure is so extreme that a human body would be destroyed in an instant. A place known as the Mariana Trench. Located in the western Pacific Ocean, the Mariana Trench is the deepest known point on Earth. Its lowest region, Challenger Deep, reaches nearly 11 kilometers beneath the ocean's surface. If Mount Everest were dropped into the trench, its peak would still be more than 2 kilometers underwater. At those depths, the pressure exceeds 1,000 times the atmospheric pressure experienced at sea level. Few machines have ever reached the bottom. Even fewer have survived long enough to explore it. Which raises an obvious question. Why would NASA, an agency created to explore space, invest years of research and millions of dollars studying one of the most dangerous locations on Earth? The answer begins with a surprising realization. The deepest parts of our oceans may be more similar to alien worlds than any environment found on land. For most of human history, scientists assumed the deep ocean was lifeless. The reasoning seemed simple. No sunlight, near freezing temperatures, crushing pressure, no obvious source of energy. Life, as far as researchers understood, required sunlight. Without sunlight, ecosystems could not exist, or so they thought. Everything changed in the 20th century. When researchers finally began reaching extreme depths, they discovered something astonishing. Life was already there. And not just a little life. Entire ecosystems. Creatures unlike anything found closer to the surface. Strange fish with transparent skin. Giant amphipods. Bacteria thriving in complete darkness. Organisms surviving under conditions once believed impossible. The discovery forced scientists to rethink one of the most fundamental assumptions in biology. Maybe life does not need ideal conditions. Maybe life simply adapts. And if life could flourish in what was once considered an impossible environment on Earth, what might be hiding elsewhere? That question eventually caught NASA's attention. Because scattered throughout our solar system are worlds that appear just as hostile as the Mariana Trench. At first glance, they seem completely uninhabitable. But beneath their frozen surfaces, scientists suspect something extraordinary may exist. The leading candidate is Europa. Europa is one of Jupiter's largest moons. From a distance, it appears lifeless. Its surface is covered in ice. Temperatures plunge to nearly minus 160 degrees Celsius. Radiation constantly bombards the moon from Jupiter's powerful magnetic field. Nothing about Europa looks welcoming. Yet, many scientists now believe it may be one of the most promising places in the solar system to search for alien life. The reason lies beneath the ice. Evidence gathered over several decades suggests that Europa hides a vast global ocean below its frozen shell. An ocean that may contain more water than all of Earth's oceans combined. Think about that for a moment. One of the largest oceans in the solar system may exist on a moon orbiting Jupiter, and almost nobody knew it was there until recently. The implications are staggering, because water is one of the key ingredients for life. Where there is water, scientists begin asking difficult questions. Could life exist there? And if it does, what would it look like? To answer those questions, NASA needed a place to test ideas, a place where life survives without sunlight, a place where pressure reaches unimaginable levels, a place that mirrors the conditions expected beneath Europa's frozen ocean. The Mariana Trench became the perfect laboratory. Every expedition into the trench teaches scientists something valuable: how machines behave under extreme pressure, how life adapts in darkness, how ecosystems function without energy from the sun. One of the most important discoveries came from hydrothermal vents. These vents form when seawater penetrates deep into Earth's crust and becomes superheated before erupting back into the ocean. The result is an environment unlike anything else on the planet. Temperatures around the vents can reach hundreds of degrees Celsius. Mineral-rich fluids pour into the surrounding water. And despite the darkness, life flourishes. Entire ecosystems depend on chemical reactions instead of sunlight. This process is known as chemosynthesis. Instead of using solar energy, microorganisms extract energy directly from chemicals released by the vents. These microbes become the foundation of entire food chains, which means life can survive without sunlight at all. That single discovery transformed the search for extraterrestrial life, because if hydrothermal vents can support life in Earth's deep ocean, similar environments might support life elsewhere, including Europa, including Saturn's moon Titan. Perhaps even world scientists have not yet discovered. Suddenly, the question was no longer whether life needed sunlight. The question became how many different ways life could exist. That realization triggered a new era of exploration. NASA began developing advanced underwater technologies capable of operating in extreme environments. Some of these machines were designed specifically to test equipment that may one day explore alien oceans. The challenge is enormous. The deeper a vehicle descends, the greater the pressure becomes. At the bottom of the Mariana Trench, every square centimeter experiences crushing force. One tiny structural weakness can lead to catastrophic failure. Several experimental systems have already been destroyed, attempting to reach such depths. Yet, each failure provides valuable data, because one day, future missions may face even harsher conditions beneath the ice of Europa. And unlike the Mariana Trench, Europa is more than 600 million kilometers away. There will be no rescue missions, no emergency repairs. Everything must work perfectly. That is where NASA's long-term vision becomes fascinating. Scientists are already discussing concepts known as cryobots, robotic probes designed to melt through thick layers of ice. Imagine a machine landing on Europa's frozen surface, slowly drilling downward through kilometers of solid ice, month after month, year after year, until it finally reaches the hidden ocean below. Then imagine what happens next. A second vehicle emerges from the probe, a miniature submarine, the first machine in history to swim through an alien ocean, searching for life, searching for movement, searching for anything that should not be there. The technology does not yet exist in its final form, but researchers are actively studying how such missions could work, and much of that research begins in Earth's deepest oceans, which is why NASA continues returning to places like the Mariana Trench, not because they expect to find aliens there, but because the trench may provide the closest possible preview of environments hidden throughout the solar system. The irony is remarkable. Humanity dreams of finding life among the stars. Yet the knowledge needed to achieve that goal may be waiting at the bottom of our own planet. The deeper scientists explore Earth's oceans, the more surprises they uncover. New species, new ecosystems, new biological strategies that nobody believed possible. Every discovery expands the boundaries of what life can endure, and every expansion increases the odds that life exists elsewhere. Perhaps beneath Europa's ice, perhaps beneath Titan's methane seas, perhaps on worlds orbiting distant stars. Because if life can survive in darkness, pressure, freezing temperatures, and complete isolation, the universe suddenly becomes a much larger place. And that leads to a possibility that is difficult to ignore. Maybe the greatest obstacle in the search for alien life was never distance. Maybe it was imagination. Maybe life is not rare because the universe lacks suitable environments. Maybe it is rare because we have been looking for it in the wrong way. The Mariana Trench continues to challenge everything scientists thought they knew about survival. And with every new expedition, the line between Earth's deepest ocean and the oceans of distant worlds becomes a little harder to distinguish. Somewhere beneath kilometers of darkness, hidden beneath pressure that would instantly destroy us, life found a way. The question is no longer whether life can exist in extreme environments. The real question is, how many extreme environments are hiding life right now? And if one of those oceans is waiting beneath the ice of Europa, what might already be swimming there? Thanks for watching. Do not forget to subscribe for more history mysteries.